Continuing here with part 2 of Animal Nutrition Unit 4, and we're going to cover in part 2 the monogastric digestive tract and the ruminant digestive tract. So let's jump right to it and hit the concept of digestion first off. Of course, we have both mechanical and chemical digestion. Mechanical digestion is exactly as it sounds. That's think of the chewing action that occurs in your mouth as you start to consume food. Also, always understand that there's peristalsis that occurs in the gut, and that's the rhythmic muscular movements that help mix the feed with the chemicals that are in there, as well as sometimes we have some grinding action going on depending on the species. And of course then the chemical digestion is done through hydrochloric acids and pepsins, and we'll talk about a number of those things later on through the section. Clearly you should know the difference in carnivores and omnivores. Just to understand, we're going to talk about a mixture of those two throughout this unit. Let's get to the monogastric digestive tract here first. Let's start in the mouth, and we talk about the monogastric, and clearly we have mechanical chewing and swallowing here, but in our mouth the teeth are perfectly aligned top and bottom for the most part, and that is due to the ability to chomp and cut food into smaller pieces before we swallow it. There's also salivary glands in our mouth, and that allows us to already introduce some pepsins and some key digestive juices into the mouth to help that chemical process already occur. Think about the esophagus simply as a garden hose. It's just very, very much a delivery tube to deliver feed from the mouth all the way to the stomach, controlled by a valve opening at the top of the stomach. The stomach then clearly is just a primary area of feed particle reduction in size and kind of a little chemical warehouse where we start to get a lot of that chemical breakdown, digestion of feedstuffs. Moving on then real quickly into the small intestine, we have three areas of the small intestine: the duodenum, the jejunum, and the ileum, basically split into thirds. The duodenum, still you're going to see a little bit of introduction of key gastric juices into the small intestine where the feed product is. It's very soupy at that point in time, but you still might be able to pick up pieces of corn and things of that nature out in the duodenum. By the time feed product reaches the jejunum and ileum, and if things are going as we schedule in the monogastric, it's basically just like a broth almost when it gets to the jejunum and the ileum, as that area of the digestive tract, the gut is absorbing key feed ingredients out of there, the key nutrients, amino acids, fats, etc., those molecules that are very important, and absorbing it into the lymph or blood. Then the large intestine contains the cecum and the colon, and its main function is to absorb, or what we call resorb, water. And it won't resorb all of it, obviously, but we take out most of the water at that point in time and then form the indigestible waste, or the fecal material. Here's a diagram of the pig digestive tract, and if we start on the right side of your slide, notice the mouth and then the salivary glands right there. A relatively small stomach, very much like ours. The pig digestive tract and humans are very, very similar. Hadn't talked very much about the liver yet. Key breakdown of feed nutrients in the liver, especially fats. Some of the carbohydrates are absorbed there. We'll get some filtering of toxins and so forth in the liver. And then you see back from that the pancreas. The pancreas is responsible for inserting a lot of very critical digestive enzymes into the digestive tract, kind of right at the start of the small intestinal tract. Moving on to the chicken, and you see some key differences here, and most of them right early on after the esophagus, the crop, the proventriculus, and the gizzard, to where you primarily see a lot of mechanical grinding of whatever feedstuffs. And so in almost all poultry rations, you're going to see some kind of grit. Oyster shells is the main one that will be inserted into the ration, and that is to help create that grinding action for the poultry. The horse is kind of altogether different, kind of a blend of the monogastric digestive tract and the ruminant digestive tract. A horse has upper and lower incisors like a monogastric, very small stomach, and then a small intestinal area that dumps, as you can see towards the right side of the slide, dumps into the cecum. The cecum is a huge apparatus in the horse where you find a lot of hindgut digestion, is what we call it. Lots of fermentation going on there. So that hay product that horse might be consuming, essentially, other than being chopped up a little bit in their mouth and added a little bit of mucus so it gets all the way down to the cecum, hasn't had a lot of digestion to it until it gets to the cecum and undergoes a lot of fermentation with the microbes that are available there. And then, of course, then we proceed into the large and small colon before it hits the rectum and we excrete the fecal material. So key critical difference to the horse there. In the ruminant, and I should back up and talk about the ruminant mouth. The ruminant mouth does not have upper incisors, so as a cow goes to pick pasture grass, she reaches down with her mouth and clamps it and rips it out instead of picks it or cuts it like a horse might. Also, the jaw is offset a little bit. That creates a kind of a circular grinding action. And there's also no salivary glands. We insert mucus into the ruminant mouth, but there is no chemicals that get dumped in there. Once it goes down to the esophagus, then the feed stuff dumps into kind of a common area between the rumen and the reticulum. The rumen, a great big fermentation vat where there's tons of papillae and billions of bacteria and protozoa that help with breakdown and reduction in feed particle size, liberating some key volatile fatty acids that we use for energy, making amino acids, and so forth. The reticulum then is also known as a honeycomb, sits right next to the heart, initiates, we think, the mixing of the rumen, which should occur about 2 to 3 times per minute. And the reticulum also catches any foreign objects like a bolt or a screw or a piece of wire that the animal may consume. The omasum is then the third of the 4 stomach compartments, and it's about the size of a basketball in a full-size animal. And it's also known as many folds or many plies. It's a great deal of bunches of skin with little barbs or projectiles on it that we think is basically responsible for grinding action and particle size reduction. Not a lot of other digestive responsibility, maybe some water resorption. Other than that, we're just decreasing particle size before it moves on to the 4th stomach compartment, which is the abomasum, or the true stomach, where it's very similar to that at that point in time, and from there on back to the monogastric. The small intestine is the same, into the large intestine, the cecum, and so forth. Ruminants, it's very critical that they do a process called rumination, where they will regurgitate a bolus of feed and then spend some time re-chewing it, breaking down feed particle size further, re-swallowing it, and re-salivating it. That helps keep the rumen buffered. As a byproduct of fermentation that's going on in the rumen, you're always going to have gas buildup, and those gases have to be eliminated via eructation. Here's a diagram that shows you a steer and where some of the stomach compartments would lie. A good picture here of the 4 stomach compartments of a ruminant. You see the rumen on the left, that shag carpet look, the reticulum of the honeycomb, the many plies of the abomasum, and the omasum, excuse me, and then the abomasum, very difficult to tell, but it's a lot of soft tissue with folds in it on the right photo. The esophageal groove is an adaptation in ruminants that whenever a young animal is nursing, that groove closes, and that's to divert milk into the lower part of the digestive tract, right to the abomasum and the small intestine. We don't really want milk fermenting in the rumen. When we talk about the digestive components, how feeds are actually broken down, clearly in monogastrics we have things beginning in the mouth like we talked about, and then a lot of enzymatic reactions, a lot of stomach secretions that are really working that I've listed here at the bottom of the slide. We really depend on them to liberate nutrients for us to absorb into the body and be used by our body systems. Amino acids and fatty acids, monosaccharides, all those become available then for absorption, and that absorption occurs by one of 2 methods. Either passive absorption, where we have molecules that diffuse across those membranes from areas of high concentration to areas of low concentration. So for example, you may have a lot of amino acids going through the gut area there, and that the lymph or the blood may be in low concentration of amino acids, so they'll passively absorb into kind of more in equilibrium, pass those amino acids across the membrane. Also, you have active absorption, where molecules, the little villi, which are little hairs, there's millions of them in the small intestinal wall, and they will reach out and like grab little fat molecules and pull them into the bloodstream or the lymph, kind of actively absorbing them. Liver function, we kind of talked about, metabolizing many different feed particles into the bloodstream and detoxifying things like if you get an aflatoxin product problem a little bit, that liver will sift a little bit of that out. I mentioned fermentation, and that rumen environment is a mutually beneficial relationship between the bugs of the rumen and the animal herself. And we have to keep that pH between about the 6 and 6.5 for those bugs to act the way that we want them to. Microbes are going to use a lot of the starches and sugars that are present in the rumen, and like I said, then make some good things for us, like volatile fatty acids, in which the cow then turns around and converts to energy for herself. But again, we got to get that methane gas as we have fermentation occurring. We've got to get that released through erectation, or we have a problem that we call bloat, which of course could be fatal. I mentioned the esophageal groove earlier as we kind of reach near the end of our slide set here. It's important to pull out of this slide that rumens aren't always fully functional until animals reach a little bit of age on them. So sheep is 2 months, cattle 3 to 4 months. So in essence, what we're saying here is baby calves can't really do much with hay or pasture grass in their digestive tract until they're about 3 or 4 months of age. Those rumens aren't fully functional, so if you feed hay to young calves, say less than 3 months of age, they don't really digest it very well. It just kind of sits in the rumen and doesn't really do anything. So be careful what you feed young stock. I mentioned earlier a lot of the primary organs and energy metabolism, and it's important that you kind of review that here on this slide, but we're going to move on and talk about, just kind of look at a couple different diagrams here. This would be energy pathways within the cow's body, and I don't mean to scare you with this slide, but it's important that you look at all the different complex processes as we get grains and forage that dump into the rumen and where all those different things go throughout the body. Same thing if we look at protein pathways. We have amino acids. We can also feed a product like urea that makes ammonia in the rumen that the bugs tend to like, and that will help them help the bugs make amino acids for the cow that we cannot feed. So protein pathways are likewise very, very difficult to figure out what is happening in different locations within the digestive tract, and I just show you this just to look at the complexity of things that are occurring here. If you're really interested in advanced animal nutrition, you can spend entire classes on these two diagrams that I've showed you. So some take-home messages for the middle section here in this part 2 of Unit 4 is understand the difference in the monogastric and ruminant digestive tract. And therefore then take that knowledge and know that each species should be fed very, very differently to achieve optimal production. We cannot feed each species the same way and hope to get what we would like as an ideal outcome. They'll consume different feeds very, very differently, digest them very differently, and of course we want to be efficient in what we do, so we want to be careful in how we select feeds appropriate for each animal. So that's part 2, and I'll look forward to recording part 3 and getting it out here for you to listen to in that segment.